Hello, welcome to episode 2. In the last introductory session, I spoke about different classes of ordinary differential equation, and I will first continue that discussion a little bit. So let me turn on the pen mode. Okay, so let's do this. Let's talk about some of the definition or like some of the classification of ordinary differential equation, and we I promise that I will talk about in this class first of all the homogeneous and non-homogeneous differential equations, right? But I assume you remember linearity, right? Linear versus non-linear differential equation, D. Okay. Oh, all right. So let's move on and let's talk about homogeneous. Okay, before we move on, I just want you to remember what is a linear differential equation. Okay, a linear differential equation where all the derivatives appear linearly. Okay, so the derivatives of y, basically derivative of the dependent variable, which we can sorry, derivative of the dependent variable. Yes, so if x is an independent variable, right, then y we can identify as a dependent variable. Okay, so now this should not be the case necessarily, because if you learn calculus, sometimes what happened, we identify t as a independent variable. Okay, whereas x or distance as a dependent variable. So it could be anything. It's not that we only dedicate x and y letters to dependent or independent. So, but convention wise, this is what we call. Anyway, let's move on. So, the derivative of y, a dependent variable, can be written as dy by dx. Okay, and the second order derivative could be dx y square over ds squared x. So this is how you can denote them, but there are other ways to denote them as well. For example, you can denote them like this. This one can be denoted like this. You have to be careful in that case, like what is your differentiating or independent variable, right? Now again, this can be also denoted as dot. So these are different ways to express a differential equation. Okay, so for example, if this is a differential equation, dy dx plus y is equal to x, like let's just say. So this can be also denoted as y prime plus y plus x, or this can also be denoted as okay. I just want you to be familiar with the different notations. All right, so let's move on and uh, let's remember what is a linear uh, differential equation, where you have all the derivatives, for example y bar or double bar, let's just say, or second derivative of y omega squared y is equal to sine x. Okay, so this is a linear differential equation, whereas if you have this, this is a nonlinear differential equation. whereas this is a linear differential equation. Okay. Now you also know what is an order, right? This is a second order, whereas this is a first order, right? Because this is how we can determine, like, depending on the order of the derivative. Anyway, so this is just a recap. So let's go back and learn about homogeneous and non-homogeneous equation. So homogeneous equation is a differential equation DE if it has 0 as a solution. Okay, so if it has a 0 as a solution, then it is a homogeneous equation, very easy. And if not, then it's a non-homogeneous. Okay, so you remember, like on the equal side, you have your equation on one side, and on the other side you have some functions, whatnot. Okay, so if this function is equals to 0, then you get to call it a homogeneous. Okay, and if it is not 0, then it is non-homogeneous. Very simple, very simple. I hope you will remember these details. Okay, so I will just write this. So let's say this is a differential equation. Okay, can you tell what's the order of this differential equation? You guessed it right, it's 2. Okay, so now you can call this as a homogeneous differential equation. Okay, however, let's just say same equation, but you write it with a non-zero solution. This will be non-homogeneous. Okay, all right, the next topic would be partial differential equation. Partiality. So far we have been talking about ODE, or ordinary differential equation. Now let's just identify, or let's just define what is a partial differential equation. So in a partial differential equation, you will have partial derivatives. Not only that, if the dependent variable is a function of more than one independent variable, and in that case the various partial derivatives of that dependent variable with respect to all those independent variables is called a partial differential equation. So I know it's a mouthful. I'll just discuss this. So let's just say if you have a dependent variable, dependent variable u, and if you have more than one independent variables. Okay, so I'll just write it like this, variables. So let's just say you have x1, x2, x3, and so on and so forth. Okay, so if you have one dependent variable and more than one independent variable, then the partial derivatives of u, so in that case you cannot have a regular derivative, you need to use partial derivative for each of this relation. I know how I am defining this, mathematicians would go crazy, but that's the whole point. I don't want mathematician to teach engineering math. It has to be the engineer's job. Okay, so once a equation that involves these derivatives and these dependent and independent variables, then you can get to call that as a PDE. Now, PDE is the most important type of uh, differential equation that engineer can encounter, because there are so many types of PDE that are being used in day-to-day basis in different part of engineering. I can tell, like at least in two parts, like in mechanical engineering in FEM or finite element analysis method, and CFD, that is computational fluid dynamics. You use both in both of these branches, and also not just these two, in all others as well. PDE is used heavily, okay, especially in computational fluid dynamics. But the thing is, the way these PDEs or even ODEs are also being used, it's different. You identify a differential equation, and then you actually break it down to multiple linear equation and solve a linear system. And I don't want to discuss that at this point, but as an engineer, if you want some motivation, these are some advanced field where you can get to use PDE or ODE. Okay. This lecture has been already 10 minutes, over 10 minutes, so I'll just stop here. I'll see you in the next video. We'll talk about some examples of the partial differential equation and also some application of a differential equation. Okay.